Good afternoon. This is the next article from this chapter gravitation, that is G. What are the variations of the values of G? As we know, G is equal to Gm upon R square. Here, what will be the value of G when that object along the surface of Earth? This is the surface of Earth. Here, keep in mind that surface of Earth is not exactly spherical. This value of R and this value of R, this is the difference. This is equator and this is pole. This distance between center of the Earth and pole is less than the distance between center and equator. Therefore, this radius is larger than this. Radius is in denominator. Therefore, value of G and value of R are the reciprocals. Therefore, R increases, G decreases, and R decreases, G increases. At equator, there is a smallest value of G as a 9.78 meter per second square, and at pole, largest value of G, that is 9.832 meter per second square. This is the value of G on the surface of Earth. What will be the effect on the value of G when we consider height? Again, we consider Earth and height, suppose small h, and this is R. As compared to R, h is very small because R is say 6400 and h is very small, 10 kilometer, 20 kilometer. Therefore, when we consider height, G is always same, and that height is, we can ignore it or negligible, you may say. This is about the height. Next, when we consider what are the values of G as we go into the depth of Earth. Here, important thing is that this part, mass G is equal constant, m mass of Earth, r radius of Earth. This mass decreases because concentration of mass at the center of the Earth. Part of the Earth is distributes, or you may say contributes to all part, and hence m decreases, therefore R also decreases, and hence G simultaneously decreases. This is the variation of the value of G when we consider in depth of this, or as we go deep inside the Earth. That is, the value of G decreases as we go deep inside the Earth. Next concept, what are the differences between mass and weight? Mass and weight. Symbol of mass is m and symbol of weight is w. Mass is a scalar quantity while vector quantity is weight. That is, weight is vector quantity. Scalar quantity means only magnitude, and vector quantity means magnitude as well as direction. Because weight is also called as force, and force is vector quantity. Weight is also called as force. Mass cannot change. Mass is always constant. But weight can change at different location. On Earth, weight is different than Moon. But mass is same on Earth, on Moon, etc. Here we know that inertia, higher inertia when higher mass. Mass is more, inertia is more. Unit of mass is kilogram, gram, and unit of weight is Newton, dyne. Formula to calculate mass is nothing but Ef is equal to mg, because Ef is W, weight is W, and m is mass. G is the, we consider G as a 9.8 meter per second square. Then by calculation we can calculate it. Suppose mass of one object is 75 kilogram. Then weight of that object is 75 into 9.8, that is 735 Newton. This is the difference between mass and weight. Now, next an important thing is free fall. What is free fall? Mukta, free, mukt. Free fall. When stone is released, and this is the ground, say, and this is the stone, and if this object is released and there is only force due to gravity, there is only force due to gravity, then stone is released, and then that type of fall is free fall. If there is only force of gravity. Here initial velocity is 0. Due to acceleration, that velocity goes on increasing when it moves towards ground. We know that from surface of earth there is atmosphere, therefore there is air layers. Hence, when stone is released, there are many types of frictional force, beyond force, which opposes to this velocity. Therefore, free fall easily do not occur in this situation. Therefore, we say that true free fall is possible only in vacuum. If there is no air, no frictional force, no beyond force, means it appears only in space at this place. Means free fall is possible only in vacuum. Here we know that the equations of motions, V is equal to U plus AT, S is equal to UT plus half AT square, as well as V square is equal to U square plus twice S. When we consider free fall, then U is equal to 0, and G, which is a gravitational acceleration, therefore we replace G as A as a G and U as a 0. Then these equations converted into V is equal to U is 0, A is G, therefore V is equal to GT. S is equal to, this is 0, half GT square, and V square is equal to 0 square plus twice GS. This is about the free fall and equations of motion. Sign convention of a G is as like this. When object thrown upwards, what I say? When object thrown upwards, then acceleration is negative. That is, G is a negative. And when it comes from that direction on surface of Earth, G is positive. This is magnitude of G is same, but velocity of object decreases because of this negative acceleration. As we go upwards, then velocity goes on decreasing. Therefore, this is negative acceleration. And velocity goes on increasing. Therefore, this is positive acceleration. These are also sign conventions which are used to calculate problems. Okay. Let us see next time, next part.